Welcome to an insightful exploration into system design patterns, where we deconstruct real-world architectures to understand their underlying principles. In the vast landscape of software engineering, distributed systems power nearly every aspect of our digital lives, from social media to e-commerce. Designing these complex, scalable systems is a monumental challenge, demanding more than just coding skills. It requires a deep understanding of how components interact, handle failures, and evolve over time. This is where design patterns become indispensable. Our journey begins with microservices, a foundational architectural style. Instead of a monolithic application, microservices break down an application into a collection of small, independently deployable services. Each service runs its own process and communicates through well-defined APIs. The core benefit of microservices lies in their independent nature. Teams can develop, deploy, and scale services autonomously, fostering agility and accelerating development cycles. A failing service can be isolated, preventing cascading failures across the entire system. However, microservices introduce new complexities, such as distributed data management, inter-service communication overhead, and operational challenges. Managing a multitude of services requires robust monitoring and deployment strategies to maintain system health. Next, we delve into event-driven architectures, or EDA, a paradigm where services communicate by producing and consuming events. Instead of direct requests, services publish events when something significant happens, and other interested services react to these events. In an EDA, an event producer generates an event, which is then sent to an event broker or message queue. Event consumers subscribe to specific event types and process them asynchronously. This decouples producers from consumers. The advantages of EDA are profound: loose coupling, enhanced responsiveness, and improved scalability. Services don't need to know about each other's existence, only about the events they care about, making the system more flexible and resilient to change. Consider an e-commerce platform. When a customer places an order-placed event is published. Multiple services, inventory, payment, shipping, and notification, can consume this single event concurrently and process their respective tasks. A key pattern within EDA is publish/subscribe, or pub/sub. This messaging paradigm allows senders of messages, called publishers, to categorize messages into classes, without explicitly knowing which subscribers will receive them. Subscribers express interest in one or more classes of messages, known as topics, and receive only those messages. The pub/sub system handles routing messages from publishers to the relevant subscribers, facilitating highly scalable and decoupled communication. As systems grow, services frequently need to find and communicate with each other. This is where service discovery comes into play, acting like a dynamic phone book for your distributed application. It enables services to locate network locations of other services. Service discovery typically involves a registry where services register themselves upon startup and deregister upon shutdown. Clients can then query this registry to find available instances of a particular service, abstracting away network topology. This pattern is crucial in dynamic environments where service instances are frequently scaled up or down, or replaced due to updates or failures. Without service discovery, clients would need hard-coded addresses, leading to brittle and unmanageable configurations. Finally, we explore circuit breakers, a vital pattern for building resilient distributed systems. When one service calls another, there's always a risk that the called service might be unavailable or slow, potentially causing the calling service to block or fail. A circuit breaker monitors calls to an external service. If a certain number of consecutive calls fail within a defined timeframe, the circuit trips and future calls are immediately failed without even attempting to reach the problematic service. After a timeout, it attempts to close again. By understanding these patterns, microservices for modularity, event-driven architectures, and pub/sub for asynchronous communication, service discovery for dynamic routing, and circuit breakers for fault tolerance, we can design systems that are not only powerful but also robust. These patterns, when thoughtfully applied, resolve specific problems inherent in large-scale systems, allowing architects to construct resilient, scalable, and maintainable applications that stand the test of time and evolving requirements.